Let us discuss this example. We have a set B, which is a subset of set of complex numbers, okay, and we have to prove that it is an open set with a usual distance in C, that means set of complex numbers. So first of all, we will try to understand what is a given set, and then we'll go for the proof of, that means how to prove it is open subset, okay, of C. So let what I do, I consider Z belongs to this set B. If Z lies in B, then obviously it will satisfy its condition. So therefore, what can I write? That means mod of real part of Z is less than X. See, real part of Z, mostly we write in this way, complex number. Z is equal to, mostly we write X plus Iy. So its real part is X and imaginary part is Y. So real part of Z means mod X less than A. Implies, so you know that there is standard result mod A less than B if and only if minus B less than A less than B. So therefore, by using this result, I can write minus A less than X less than A. So that means X, real part of Z, always lies between minus A and A. So we can write, so therefore we get a region bounded by X is equal to minus A and X is equal to A. So if I draw the diagram, it will be like this, okay. So this is y-axis, or you can say imaginary axis. This is real axis. So X is equal to A. X is equal to A. It will be here, getting X is equal to A. So this is a line, X is equal to A. Similarly, we have X is equal to minus A. Line will be here. X is equal to minus A. So we have a region which lies between X is equal to minus A and X is equal to A. So this is a region bounded by these two lines. Okay. So after that, we have to prove it is an open set. Now we will prove that B is an open subset of C, obviously with usual distance, okay. So what is the technique, what is the method which we follow? We take one arbitrary point, right, and we find ball around it which entirely lies inside a set, then we can declare it as an open set. Let us do the same. Let Z belongs to B be any arbitrary point. I have taken one arbitrary point. Now we have to draw ball around it which entirely lies inside a set. Suppose Z is here. Suppose Z point is here. I have taken. Okay. So that means obviously it will satisfy the condition. So therefore mod real part of Z less than A. So it satisfies the condition. Getting? So therefore, what can we write? 0 less than A minus mod real part of Z. What I have done, I have shifted that mod of real part of Z on that side. It has a plus sign here. So if you shift there, it will have minus sign. I will call it as R. Some positive number we have got now. I will call it as R. So let R is equal to A minus mod real part of Z. Then clearly I can write this R will be greater than 0. This is greater than 0 because we have already written this is greater than 0 and we have called it as R. So therefore R is also greater than 0. So now my claim is open ball with center Z and this radius R will entirely lie inside a set. Okay, will entirely lie inside this set B. This thing we are going to prove. Okay, make a screenshot of it. After that we will go further. See, now we have to prove this open ball with center Z and radius R entirely lies inside a set. What is the technique to prove one set is subset of other? We take one arbitrary point from first set. We have to prove it is in second set. Let us do. Let I am taking arbitrary point W belongs to open ball with center Z and radius R. So that point W lies in a ball. That means obviously distance of that W from center of ball is less than its radius. How to find distance? They have mentioned it is a usual distance. That means it is mod W minus Z less than R. Since it is usual, mod is there. Okay. So W is a complex number and Z is also a complex number. So that's why it will be in this form. U plus IV, it's a complex number. Minus Z means I will call it as A already we taken na, so I will call it as X plus IY less than R. Okay. How to subtract real part minus real part and imaginary part minus imaginary part? So that's why U minus X, real part minus real part, plus imaginary part minus imaginary part less than R. Do you know how to find mod of a complex number? Yeah, it is square of first plus square of second. Okay, so less than R. So yeah, in complex number we do the same. Square root of square of real part plus square of imaginary part. So now square root is there. To remove square root, I will take square of both sides. So that's why it will be U minus X square plus V minus Y square less than R square. See, sum of these two is less than R square. That means 100% each of them is less than R square. So what can I write? So therefore, U minus X square less than R square. This one is also less than R square, but it is not required. Okay, let us skip it. So I will take positive square root of both sides. So mod U minus X less than R by taking positive square root of both sides. But there is one result, I haven't told you. That result is mod U minus mod X less than or equal to mod of U minus X less than R. So that result is, I will mention here, mod of mod A minus mod B is obviously less than or equal to mod A minus B. This result, okay, or this inequality of real numbers we have used here. Getting? So A less than B, B less than C. So directly we can write A less than C. So therefore, mod U minus mod X less than R. So you are familiar with that result of modulus mod A less than B if and only if minus B less than A less than B. So let us write it, minus R less than mod U minus mod X less than R. See, this inequality is not required. I will consider only these two terms. So that means mod U minus mod X less than R. Getting? But what is U? What is U? U was real part of W. I have written somewhere, na? Yeah, W is equal to U plus IV. U is real part, V is imaginary part. And what is X? That is real part of Z less than R. So the question is, what is R? You remember our definition of R was A minus mod real part of Z. So what will happen? Minus real part of Z minus mod real part of Z minus mod real part of Z will get cancelled to each other. So therefore, mod real part of W is less than A. Okay. No more space is there. So make a screenshot of it. After that, we'll go for next part of this example. See, basically this is condition of set B. Getting? The mod of Z is less than A. Here we have got mod of real part of W is less than A. That means W is W satisfies condition of B, therefore W is an element of B. So that means we can write W belongs to B. So therefore basically W was taken from that open ball with center Z and radius R, and we proved that W lies in B. So therefore this open ball subset of B. So therefore I can write, therefore this open ball with center Z radius R subset of B, and it is true for each Z, na, since Z was any arbitrary point. So therefore we can declare B is an open subset of C. So therefore we can write B is an open subset of C, obviously with usual distance, with usual distance. So see, in this way we have completed this example. You can make a screenshot of it. After that we will stop. Thank you. Bye bye.